So again, I'm recording this and I will be posting this one in so later on. So today we will discuss, continue discussing with our uh, lesson uh, on computer concepts and fundamentals. I hope that you already downloaded the tools that we will be using once we start with programming later on. Uh, Again, I posted there a YouTube video on how to uh, download and install code blocks. And the code blocks will be used for our session maybe at the end of September. And we will be using that to demonstrate programming in this subject. Okay, so I hope you already download that one. So today we will be discussing about computer concepts and fundamentals. So basically, a summary for this today's discussion is we are going to talk about computers, how computers are made, or what are the different concepts, the technology behind computers, and how it is made today. Okay, to start off our contents, we'll try to look at introduction to computers, characteristic of computers, history and evolution of computers, different generations of computers, computer organizations, and computer classifications. So I think basically you already know what is a computer is. So basically you are watching or you are using computers today. So that's the basic part of what is a computer. So as an introduction, basically computer is a machine that performs calculations and computations. Now, this definition has been changed because uh, computers can do more than calculations and computations. No? So basically, this is a class definition of what is a calculator. So a computer is redefined as a device that manipulates data according to a list of instructions. So that is why it requires a program for a computer to work. No? Or the computer requires a software in order for it to work. And a software requires a hardware for you to interact with the computer. So again, there is what we call a software and there is what we call a hardware of computers. So it is an electronic device that is used for information processing. So it is trying to transform any data and transform it or process it into what we call information. So again, data is raw data. These are values of ones and zeros or any calculations, computations, numbers. Then it is processed and it becomes information in which we humans understand. So the word computer was originally a job title. So you can see there in the picture in 1949, those ladies there are what we call computers. During that time, it is like engineering today. It's a job title. So if you're an engineer, in the past, there is what we call a computer. So it's very awkward seeing people uh, calling themselves a computer. No? So that was the origins of computers during the past, in which they will hire brilliant people to do computations for them. And usually, what they do for this one are uh, they employ 20 to 30 people to do these tasks for them. So next is what is information processing system. So a computer undergo this IPS system. No? So it means information processing system in which data is collected and it is unorganized. So let's say, for example, in the input part, data is collected, then it is processed, no? Then it is stored, either processed or stored, then eventually it is an output, no? And becomes an information. So I'll give a very good example of this one is that, let's say, for example, data. A good example of this one is a keyboard stroke. So let's say you press a key in your keyboard, that's data. And for the computer, it is just a value for them. So then what's next? It is then processed by the computer, and then when it processes, it says there, okay, the compute, you are hitting the Q button, therefore I will display it in the screen as an output. So again, information processing system is transforming data, which is a raw fact, independent data, and transforming it for a more understandable information for us. So in a computer system, it's quite similar, but it has fine-tuned and has multiple elements, or parts. So it's the same thing as your information processing system. There is what we call your inputs. So a good example of inputs are your mouse, keyboards, what else? USB reading, and so on. Then it is processed in the system, which has several components, which has a control unit, which controls everything from storage to the ALU system, which is the arithmetic logic unit. So the computer then stores it in RAM, a cache or a ROM, then eventually process it into the ALU, and it is processed there either arithmetically or logically. Then once it is done calculating, then it is processed as an output. And a good example of outputs are your monitor, printers, and so on. Okay, so that is what we call a computer system. The next one is computers. Computer performs computations and make logical decisions. So computers, millions, billion times faster than human beings. That is why obsolete na ng tao nga computer, and it is replaced by programs or hardware computers. So when you say computer programs, this is a set of instructions in which computer processes data. And there is what we call the hardware, which is the physical device of a computer system. And there is also the software, which runs on the computers. I think you know already those definitions. So here is an example of components of a computer system. So there is an input device, mouse, keyboards. Then it goes through the processing unit, your CPUs, and goes into your RAM. Then goes to the secondary storage if you want to save your file information, and goes into the output devices, which are examples. There are your monitors and speakers. So what is the characteristics of computers? So computers are it has a high processing speed. It is very accurate. It's reliable. When you say reliable, it means that if you do run it again, it still uses the same results, or the output will still be the same. Versatility, it can be in other forms, and of course, diligence. So to look into the past of computers, we all know that computers were not considered as computers. They are just people. But before that, there is what we call calculators, or we call this one tools to aid them in calculations. Now, if you are going to uh, divide the timeline of computers, you just divide it into two. We have the first half will be the analog era, and the second half will be the digital era. That's why uh, we always hear the saying we are living in a digital world. Huh? So the first half, which is the analog uh, era, is also subdivided into two parts. So the first part of the analog era is what we call the calculators or the manual computations. No? So they are using what we call abacus. They are using uh, different types of uh, devices to help them in calculating. Then the second part of that is they develop machines. Instead of doing manual calculations, they have already created machines, and this is what we call the mechanical machine calculators. So a good example of that one is in 1642, we have Blaise Pascal, a French mathematician, who devised or created what we call as the Pascaline. And this Pascaline machine was a helping tool for his father in doing taxes. No? So Blaise Pascal developed that software to help him, uh, hardware to help him with some tax collection. And afterwards, in 1971, we had Gottfried von Leibniz, who discovered or who made the step recorder. No? So this is still in the age of where there is the computers are still in mechanical part. So we have there in 1822, Charles Babbage made his difference engine, a machine designed to automate computation, tabulation of polynomial functions, which are known to be good approximation of many uses and functions. So this difference engine was usually placed in boats to fire accurate cannons in World War I and World War II. So it is there to calculate for the trajectory of cannons during that time. Then later on in 1833, the Charles Babbage created another one, which is the analytical engine. But he died before he could build it. It was built after his death, powered by steam. So electricity was not yet invented or discovered yet during that time. So the first programmer was a love interest of Charles Babbage in the name of Ada Byron. So she is the first computer programmer in the name of Ada Byron. So he made some sort of program for the analytical engine. Now, in the second part, as I mentioned, we have there two eras, the analog and the digital. And the first era was calculators. It's divided into two, which is the calculators, and then later on to the mechanical machines. Then, of course, we found or discovered electricity. And that is now, we are now leaning to the digital age. So during this one, we have 5 generations already. The first generation is the mechanical calculator. So it's generation 0. Then later on, since we discovered electricity, then we were able to create vacuum tubes for computers. So we are able to create what we call a transistor. And during that time, the ENIAC, which is the Electronic Numerical Integrator and Computer, was unveiled in 1946. So we can see there how the computer looks like during the age of in 1946 to 59. So you can see there that it's a very big room. Then later on, through the development of vacuum tubes, we then transitioned to transistor computers. And the first one was the IBM 1794. And you can see there, we are already going through smaller, we are going to smaller and smaller computers. Then later on, with transistors, we develop what we call the integrated system, or ICs, or what we call chips, microchips. So this one are these are, because of that, we are able to create very powerful computers. No? Then later on in generation 4, we have now the microprocessors, 1970 to 1990s, which is a very large scale integrations, VLSI. And this is the development of computers that was during the time of Bill Gates and Steve Jobs. So today, we are currently in generation 5, so in 1990 to the present, and we can see greatly the influence of what we call the Moore's law, which signifies that computers will become smarter, computers will become smaller, computers will become faster, and so on. So that's the timeline of the history of computers. We started off with abacus, mechanical computers, then later on we discovered electricity, then vacuum tubes, then transistors, then integrated circuits, and now we have what we see in front of our desks, our computers today. Okay? So to classify, again, as I mentioned to you, there are two types of computers or classification of computers, the old one and the new one, which is digital. Now, the old one is the analog, while the other one is digital. So if we still live in 1920s, then our computers are called analog computers. So what does it, how do you classify it as an analog computers? So again, all analog operations are performed in parallel, and data are represented as voltages, a very compact but not necessarily bus for of storages. So voltages, or even steam engines or rotational parts. Then, of course, if you classify it as digital, these are all operations are performed in either parallel or series. It's now transitioning to series. Stores data in terms of digit numbers and proceed in discrete steps from one state to the next. Sometimes they are called hybrid computers because it can also operate in analog. But today we often see less analog computers than digital. So that's why, again, we are now living in a digital world. So to say parallel, what does it mean? Parallel mean that it is sending methods in signals over a communication link at one time. So it means that if you are sending information A, B, C, D, E, F, it sends information at the same time. So you call that one as a parallel. Then in terms of storing data or representing values, they are using voltages. So data representation in analog computers. So it varies continuously with a certain range like -10 to positive 10 volts. So you can just imagine using trigonometry, using integration and differential equation to calculate the storage devices that you will have during that time when we have analog computers. That is why only genius people can handle those computers, because it requires lots of computations by itself. The next one is digital. So if you are in a digital digital computing, then series is the method already. A method of sending several data over communication link in sequential order. So instead of just parallel, meaning data is sent at one time, all of the information is sent at one time, data is sent in sequential order. So instead of A, B, C, D, E, F, D, then you are sending it A, B, C, D, E, F, one at a time, and when it reaches your destination. So to differentiate it back to analog, just remember that analog is just like a shotgun, while digital computers are more likely like a machine gun. No? So in a shotgun scenario, data are scattered everywhere. There is no direct path. Each pellet can interact and disrupt other pellets. But in this case, in series, there are tendencies that the errors in sending information is lessened because of that. Now, in terms of voltages, by the way, save na siya. It is now uh, we have 10 minutes. No, 10 minutes. By the way, we are having 10 minutes lang. Wait, ha? Sige, sige. Anyway, once the session here is finished, can we switch back to Google big blue button, because again, time limited na ini siya ang session 3. But I will finish everything here. So again, in this case, instead of voltages, set na siya, it is already in states. So when we deal with states, it means that it is already in ones and zeros. Okay. So a computer now in digital format is that you will be dealing with ones and zeros. So classification of computers, we have mainframes, mini computers, microcomputers. So the difference is the size, the operation, amount of data that can be stored, and the number of simultaneous users. So when you say mainframes, these are very big computers that handles lots of computing power. So these computers are used by large organizations. Then we have mini computers, like mainframe computers are used for big businesses and organization. So in microcomputer, we have our PCs. So it is now classified as PCs now. Then later on, PCs are classified into desktop, laptop, other. So PCs, personal computers, are considered as desktop, laptop, laptop servers, workstations, smartphones, and wearables. So when you say desktop, again, it is placed at the desk. Laptop, it's placed in your lap. It's very mobile. Palm tops or handhelds for your palm. Servers, these are dedicated for serving operations. Serve other computers, connect other computers. Workstation, multiple microprocessors doing specific tasks. I think you have seen these workstations oftentimes in YouTube, where you can see different multiple screens. Then we have smartphones, and of course, we have wearables. Okay? So, I think medyo paspas na ta. So that is, I have 5 more minutes. That is basically the history of computers. Okay? So, any questions so far in this topic? Just put there in the chat if you have questions. Now, so basically, the computers are has a different world than us, no? In terms of their languages. they have different ways of communicating. Unlike us, we use our English. The PowerPoint presentation is already in the Google Classroom, so you can in the Google Classroom in the Soul, so you can get a copy there or download the copy there. So again, since we're running out of time, I will discuss our activity. I will just lang din na. I have 5 more minutes to tell you about the activity number 1. So basically, this is a movie activity ni siya. So this is the first time that an instructor tells you to watch movies. No? So I have their list 1, 2, 3, 4 list of movies that you are going to watch. So not all, no. You need just to watch one of them, depending on what type you like. So you can choose one of that. Then after watching that one, submit to one page essay and one movie listed. Your essay must answer the following question. What is the movie all about? What technology and innovation that contribute to the development of our technology? What have you learned from the movie? Both historical and moral lesson learned. And compared to computers now to the system used to the movie, what are the differences? Okay, so any questions with the activity number 1? Do you have questions? So sayon ra kayo inyong task, no? For this week. For this week, you are going to watch a movie based on those lists. Now, again, I would suggest it's very interesting movies na siya, no? If you want, you can watch all of them, but you only need to submit one essay lang jud. So you pick one and you can submit. The deadline is also posted in Soul, so you can look at the Soul for when to submit your discussions or essay. So if there are no more questions, if there are no more questions. So today is just a relaxing day. Basically, we are just telling about computers, what's different about computers, what are the history of computers. And later on, we will, next week, we will now discuss on starting to go more focus on data, on programming, how to program, what are algorithms, what are flowcharts, and so on, to prepare you for the grit and grimy discussion, which is programming. Okay, so any more questions? We have 3 minutes left to discuss if there are questions.
Sir, question, sir.
Yes.
Are you going to upload the PowerPoint presentation, sir? Soul?
Yes, it's already there. Actually, it's already there.
Okay. Sige, thank you, sir.
Okay.
Okay. Thank you, sir.
Okay. Any more questions? So I hope that you already download the code blocks, because maybe 2 weeks from now, we will be using code blocks already. Make sure it's already working or you tested it out. There is also an instruction there in Soul in which you're going to test the one. So any more questions about the history of computers? Wala na, pangutana, ano naginana. So if there are no questions, since we have already 1 minute and 30, I can dismiss you early, and I hope that you will start watching the movies that I have listed, so that you can watch everything. And those movies are very interesting and eye-opener also. Any more questions? We have 1 minute and 10. Wala. Anyways, I will be posting a forum in the computer in the Soul, in which you can post your questions. Okay. No more questions. And by the way, I hope you always manually check your attendance, no? Ayaw kalimot to check attendance. There are times nga. Last meeting, I did not record na lang ang attendance because there are also problems with